Hello, everybody, and welcome to the Wednesday night YouTube Model Builders presenting the Arduino workshop with Chris of MRL Trains. This is an Arduino workshop for beginners. It's a hands-on, so you need to have your Arduino breadboard and the components that come with Arduino. You can get a starter kit, comes with various components, switches, motors, all that good stuff. This show is going to be on Wednesday night at 8 o'clock Central Time. It will be aired on the first and third Wednesday of each month. So starting February the 1st will be the regular schedule. This is the first show of the Arduino workshop, and Chris is really looking forward to doing this and helping people out, because Arduino has a lot of benefits to small railroaders, which you'll find out in the workshop here. Everyone in the Q&A can ask questions during the show, work along with Chris. And if you have particular questions of anybody on the panelists, just direct a question to that and I'll read it to them. And we'll see if we get you answered out. Whoops. Yeah, wrong one. Where'd it go? I didn't start doing this yesterday, but you think I did. Anyway. Go to YouTubeModelBuilders.com to the website. You'll get the schedule for the Tuesday presentations, the live show. Thursday night hangouts are every Thursday of the week. The eMag, you'll find a place there to sign up. The eMag just came out last week. JD and his team, they've got another good one going there. So be able to check it out, YouTubeModelBuilders.com. And I think Chris is having an earthquake. All right, Chris, the show's all yours.
Okay, thanks, Johnny. Well, the big night's here. I know a lot of you guys have been waiting a while for this, and glad you had the patience and hope you had the time to get your kits in order and you're ready to build with us. So
hang on, Chris. We're not online for some reason. Daggone it.
How much? The whole time or just now?
Yeah, looks like the whole time. Hello, everybody, and welcome to the YouTube Model Builders Wednesday night Arduino workshop. We've had a little difficulty here, but now it looks like our streaming is live. It's showing me to be offline. But sorry about that, folks, for the confusion. But anyway, tonight is the Arduino workshop. This is held by Chris of MRL Trains. This is a hands-on workshop, and you'll need a Arduino starter kit where you get all the components with it, switches, LEDs, resistors, and a whole sundry of assortment of electronic pieces. So anyway, this is to help people learn how to use Arduino, how to load sketches, which is the program, and how to manipulate a little bit for what you want to do. The Arduino has a lot of benefits to mile railroading, so this will be a really good workshop. Everybody's been looking forward to it. Chris has been putting some good work into it. I also want to let you know to go to YouTubeModelBuilders.com, and there you can check the schedule for the eMag. We just had that come out. JD and his team hit that one on the head again. Tuesday night presentations and the live show that's once a month. You can check the schedule for that and what the titles will be. So YouTubeModelBuilders.com, that's the place to go. Find out what we got going on. Well, let's go ahead and turn it on over to Chris, and let's go for take two, Chris.
All right. Well, thanks, Johnny. Well, the big night is here. We've all been looking forward to this for quite some time. I know it was a bit of a wait for those 3 weeks, but it was necessary to give people a time to get their Arduinos and their components together. But the night is finally here, so let's do this. And just as a real quick recap, the whole reason I did this was I myself have only been doing anything with Arduino for a little less than a month right now. I got my stuff right before Christmas, and as I was starting to look at things I could do with it and how I could use it for model railroading, I decided that, hey, wouldn't it be fun for a bunch of us to do this together? So first thing I'm going to tell you is I'm not an expert, and I did not stay at a Holiday Inn last night. So what I say is just what what I'm teaching is what I've learned so far. It doesn't mean it's right. I'm hoping it is, but the whole idea of this is not for me to sit there and teach anybody anything. It's for us to work through it together. And I know there's people out in YouTube land right now that are also that not on the panel that are going to build along with us. And if you're just watching this to see what it's all about and you don't have an Arduino yet, I encourage you to watch along tonight and see if it's something, I'm hoping to show you how easy it is. Maybe you'll make the leap and get an Arduino for yourself. So we have a couple panelists that are going to work along with us tonight. We've got Dave and Ken, Dwight and Lloyd. And of course, we have our host, Johnny, and Andy Crawford is going to be our resident expert in case we get stuck. So with that, I just wanted to let you know one more thing real quick that, we're going to use the building block approach here tonight. I kind of put together some slides, and I'll put those slides up as kind of bookmarks. So when you watch this video back later, or if you're not watching live tonight and you want to come back and find something, you can use those slides as a bookmark to see where we are. But we're kind of just going to use the building block approach. We're going to do an exercise and we're going to do something different. And then by the end, we'll put it together. And my goal is to make sure that every workshop we end up doing projects that are relevant to model railroading, something you can actually take away and use on your layout. So with that, tonight, I'm going to share my screen here in a second. And we are going to start out and have a show tonight on LEDs. So here's slide number 1. It's kind of a overview of what we're going to do tonight regarding LEDs, and even just starting with the Arduino itself. Since this is the first workshop, we're going to just kind of go over some of the basics of an Arduino, what it is, how to load a sketch, understanding. We're going to kind of work through as we do some of these and just kind of get a concept of what makes up a sketch, which is actually the programming. We're not going to get heavy into programming, just learn how to pick out key things and change them, copy. We're not going to, this program is not taking the deep dive into learning how to fully program your own sketches. So we're also going to build a basic LED circuit on a breadboard and then do a few experiments with those. And before the night's over, we're going to actually create a grade crossing flasher with the 2 lights flashing back and forth, and a traffic light that you could, if you wanted to build little miniature traffic lights for the streets on your layout, that's something you could do. So with that, let's see. We'll start out with exercise number 1, which is going to be to upload a sketch. And we're going to start with one of the most basic sketches out there called Blink. And at this point in time, assuming that everybody out here knows how to upload a sketch or have successfully uploaded a sketch to your Arduino, we're not going to be covering that in this class. So if you're watching out on YouTube and you have a little difficulty, you just have to go out online, find the right way to be able to do that, and then come back and watch this video and work through the exercises afterwards. So I think I should go back to sharing my screen here a little bit. Sorry for the delay here. Sometimes the computer isn't as fast as you want it to be. It's not the speed of Chris typically. So I forgot to open my Arduino sketch. So let's do that. Sorry about that. It's going to take a second. Meantime, those guys on the panel, if there's somebody that has the Arduino IDE, which is the Arduino program, open right now. Well, something happened with that computer here. So there we go. If anybody has their IDE open right now and would like to share their uploading of a sketch, because I'm having a little bit of a computer difficulty here.
This is Ken. I can go ahead and do it. You want me to show my screen? And
if you could, yeah, if you have the IDE open and you want to show how you find the Blink sketch and then load it into your Arduino.
Sure. Okay. Yeah. Can you guys see mine? Okay.
Johnny, want to share his screen? There we go.
Yeah, it's nice and black. If I remind everyone, if they can't see it well, they should enlarge their screen. It'll be a lot easier to see it.
Are you guys able to see mine?
Yeah.
Okay. So go ahead. You want me to go ahead and upload the Blink?
Yeah, you want to just show them how you go to the examples and
Sure.
Blink, yeah, just like you're doing.
Okay, sure.
And then
Yeah, you just go to File and then go down to Examples, and then up to Basics, and select the one called Blink. And that'll open a new window for you, and you can actually just close the old one if you want to. And oops, I guess that was a bad idea. Hang on just a second here. Okay, there we go. So that brings up the sketch that you need, which for those who haven't done this before, the sketch is basically the equivalent of a program that you upload to your Arduino through this program. It's very simple. Here's all your code. And you just click the little right facing arrow, or right pointing arrow, and you'll see it says upload next to that. Click that and it'll compile the sketch and then upload it to your Arduino. And then it will automatically start with your Arduino once it finishes uploading. Did that help?
Yeah.
Okay.
okay. So I've got mine ready. Sorry, share that one. So can you see that full screen nicely?
There.
Yeah.
Okay.
Right, thank you. Sorry for the problems. Get these worked out. So yeah, as showed you that Blink is, and somebody needs to make it. Okay. Okay.
Well, Ken's echoing too.
Yeah, there we go. So on the Blink, it turns on an LED for 1 second and it turns it off as. Let me back up. When you open the sketch, you're going to see that there's a lot of grayed out text, and that's called commenting. It basically helps tell you what's in the sketch. And that helps to determine what you need to do to make some simple modifications. So you don't have to learn what all the code means, but by using the little comments that the programmer put in there in plain English, it helps you really understand what the Greek-looking code means. So in this, all right, let me refresh real quick. Somebody else wants to jump in and show that they're looking at it in the meantime.
Hi, David.
Well, Ken's echoing real bad. No, there he goes. He just muted it. Just took care of the echo.
Okay, that's what I thought. Somebody was unmuted.
Yeah, sorry about that. I forgot to mute after I got done talking.
All right, so let's try this over from the top. Maybe we have this. So Johnny, if you want to put up my screen again. Okay. So as you can see, there's a little red light blinking on my Arduino right now. And what we did was we opened the blink sketch, pushed the upload button, and it literally uploaded it to the Arduino. So this Arduino, and I'm going to back up a little bit. I was going to cover this earlier and I kind of skipped over it. What the Arduino is really just basically what I like to call an input-output board. It basically relies on input, whether it's pushing a button, receiving a signal from something. So it takes that input and then it outputs something like turning on an LED, making a sound, making a servo move, something like that. So there's little programming libraries that have the instructions that tell the Arduino how to do that. And those libraries are read by your sketch. And it basically sends those in. You plug your Arduino into your computer with this USB cable. And once you're connected, it allows you to upload the information from your sketch into your Arduino. So in this case, the sketch we uploaded is basically just telling it to blink this little LED on and off, the one that you can see right here on the circuit board that's blinking. And I'm going to try opening or sharing my sketch again, and we'll just go through real quickly how you can kind of read through the sketch in simple layman's terms and understand that that's how it's telling it to blink that light. All right, are you seeing my sketch now? Or did it not share?
John, I don't see him or his sketch. I don't have an avatar, nor do I see a screen.
Okay, do you see this sketch now?
Yep.
Okay, so if we just read this real quick, it says blink turns an LED on for 1 second and then off for 1 second repeatedly, meaning over and over and over again. Most Arduinos have an onboard LED that you can control. And I won't read the rest of that right now. It's kind of irrelevant. So when I scroll down, you can see that what you're seeing right now is the entire, from where my cursor is down to the bottom, about these 10 lines of code or so are all it takes to make that LED blink. And when you look at a sketch, there's basically only 2 things you have to make a sketch. And one of them is where this line says void setup, and then down below it, there's void loop. You don't even really have to know anything about it other than anything that's in this section called setup runs once when you either plug your Arduino in or hit the reset button. And then once it gets down to the area where it says void loop, those instructions run over and over and over for eternity or until you unplug your Arduino or turn it off. So when a sketch runs, it basically starts at the top here, does these instructions, which it gets from the library, and we're not even going to care a whole lot what they really are, because we're just going to be copying this sketch and modifying it a little. Then it gets to the loop section and it does some more instructions, and those instructions it just keeps doing over and over and over and over again. And if we read the little comments right here under the loop, it says the first one, digital write, LED built-in high. Well, that's sounds like a lot of gobbledygook. We're not going to care a whole lot about it other than the fact that it says this turns on the LED. High is the voltage level. So this command is turning on the LED. The next command, it says delay 1000. That's just telling it to wait for a second, because that number 1000 is milliseconds. So 1000 milliseconds is 1 second. And then the next command, it says digital write LED built-in low. It turns the LED off by making the voltage low. Then there's delay 1000. That means wait for another second. So all it's doing is it's turning on the LED, waiting for a second, turning it off, waiting for a second, turning it on, waiting for a second, over and over and over. It's that simple. And we don't need to know a whole lot about what digital write LED built-in high means, other than we see that word high, we know that it's turning something on, and we see low, we know that it's turning something off. Because what that boils down to is all the inputs and outputs on your Arduino are basically referred to as pins. And when you make a pin high, that means it's sending voltage through that pin, like to the LED to turn it on. When you send it low, it's turning off that pin, basically turning off the power to that pin. So it's just like your light switch. Every time you walk in a room, you turn it on, you walk off, walk out, you turn it off. Basically the same thing. So in this sketch, if you wanted to modify it, and I guess before I jump to that, I'm gonna stop sharing for a second and let's see, does everybody have their Arduinos blinking right now? Anybody? Yeah, I can do that real quick. Are you still seeing my, for any of you that were unable to successfully write the sketch to your Arduino, if you look under tools and it says port, if you hover over that, it pops out, and if it won't upload, like mine says COM4, you could try COM1, switch to COM1 and then try, and I should show the upload. Once you have this little arrow right here that I'm hovering over, and then it says upload, if you click that, now you see it down here, it says compiling sketch, and off to the right there was some green. There it goes. And in this case, it's probably just going to hang here because I changed to the wrong COM port. So what it's going to do, it's going to keep trying, and eventually it's going to fail. Then you're going to get this blue bar is going to turn orange, and it's going to give you some orange text down here in the black area. That means your sketch did not successfully load to your Arduino. So if I go back now and change this to COM port 4, so you very quickly found that COM port. It's started writing to the Arduino, and hopefully it'll finish up here. I might have to start over just because I changed in the middle of it, but it's not happening. All right, so what I'm going to do is I'm just going to stop this for a second here. So there's a way I'm going to have to quit the program. I'll just give it a couple seconds, and while we're doing that, Johnny, if you want to just jump around and take a look at some of the blinking Arduinos, and then see if is everybody on the panel okay with this so far? Have it uploaded and blinking that we can.
Yes, sir.
So far.
Okay. And then there. So you know it finally turned orange. If you can see this, this means you did not successfully upload. So I'm going to go ahead and now make sure I'm on COM port here again. And here's one other thing you can do. You see the check mark at the very left up here? If you click on that, it's actually going to test your code without writing it to the Arduino. It's called compiling. It basically takes your code and writes it into something that it's going to send to the Arduino. And here again, I'm talking in very simple terms. I'm not a programmer. I'm not going to pretend to be at this point in time. And I know there's advanced people probably out there that'll be chomping at the bit, say, hey, that's wrong. But hey, we're beginners, teaching beginners, and we're learning, and we would definitely value your input. If you see something where we're way off base, but in the meantime, we're going to make mistakes, and that's what we're here for, just to learn together. There we go. So now it finally compiled. And now when I hit upload, it's done uploading already. So now if I switch back to my Arduino, And Johnny, do you have me on the camera here? Okay, because I'm just seeing your icon right now. Okay. So that's me. So I'll go back to the. Yeah, I'm not seeing my camera. I hope you guys are. Oh, there it is. Finally. Okay. So as you can see, this little light by my pointer is going to flash on and off every second for eternity. So that was a very basic, simple sketch. And I spent a lot of time on it because it's going to be the building block for a lot of things we're going to do. So what I want you to do right now, and I'm going to go back to screen sharing so you can watch me do it. I'm not sure if there's a faster way to do this. Unfortunately, there's not. But I guess for free software, we can't complain. At least we're able to share with you guys out there all over the world. All right, so can you see my sketch again? So what I'm going to do now, before we do any changing, I'm going to say File, Save As. Now this is something you're going to want to do regularly, and what it's going to do is take you out to your Arduino folder if you've never saved a sketch before, and as you can see by default it says Blink, but I'm going to save Blink EXP1, like experiment 1, and I'm going to hit Save. And what it did is it writes a folder, and then inside that folder it puts the file. And they're both named with whatever, like Blink EXP1 that I just put in there. So now I have a different copy of Blink that I can mess with and not change the original. Now, in the case of the ones that are preloaded, like in the beginning, I should have covered this better, so I'm going to backtrack a little. Under File, Examples, there's a bunch of sketches that come with this Arduino IDE, or this software program here for programming. So we went into Examples, Basic, Blink, but there's some other ones here too. If you open those up, they should have some good documentation as to what they are. They'll even tell you what you need to hook up on your Arduino. But for now, we're just going to stick to this Blink. But I like to, like any file, if you're working in a Word document or a spreadsheet, you save every so often, and once in a while you save it with a different name in case you want to go back and undo a bunch of the changes you did. So we'll call this Blink 1, Blink 2, whatever you want to call it. And first thing I'm going to do is have you guys just play around with changing the delay. So if I take the delay now and I say 500, I'll take the other one and delay it and make that 500, and then just hit the save button, which is way to the right here. It's the last one of these little icons in the toolbar. It says save. This will actually save your sketch. So now I've got a copy of Blink, and I changed the delay values to 500 instead of 1,000. Well, we know that 1,000 was a second, so the 500 will be a half a second.
Okay, let's stop right there for 1 second. When
Okay.
you just say change the values, are you talking about where it says delay and it's in black 1,000 in parentheses? We can actually delete that?
You can't, you could delete it, but then it's not going to delay. But if you change the 1,000 to 500, yes, you can edit anything actually in this sketch. You can change anything. If you change something wrong, the sketch may fail. But in this case, it's just a number, so we're just going to change the number from 1,000 to 500.
Okay, but leave the parentheses in there.
Yes, leave the
Okay.
parentheses in there.
Knowing nothing about computers in that respect. So change it to 500.
Yep. Or you could change it to 200.
Okay.
Chris, can I just say something?
Sure.
The
I want you guys jump in all you want all night long. That's what we're here for.
Okay, the 1,000 represents 1 second. 500 would represent half a second. So
Correct.
if you put 0.2, if you put 250, so that becomes a quarter of a second.
Yeah,
So-
because it's actually 1,000 milliseconds. So yeah, 250 milliseconds would be a quarter of a second. So you could put in any number you want right now. I'm just going to try 500. and then go ahead and you'll have to hit save first because it won't let you upload, I found, if you don't hit save. But then go ahead and hit upload, and it shouldn't take too long because it's already been mostly compiled. Sometimes it does, sometimes it doesn't. As you can see, the green bar on the right, lower right, is slowly filling in, and then all of a sudden it'll say done. Come on. I don't know if it's because I'm streaming tonight that this is going so slow. It usually doesn't take quite that long.
No, Chris, it happened to me too. It takes a long time at first.
Yeah, usually the first time, and then usually as you make changes, it goes pretty quick. And I thought since this was just, maybe because it's got a different name now instead of Blink, I changed the name because I did the save as.
It's blinking faster now.
Yep.
There's a way.
Shut.
Oh, sorry.
Yeah, go
There's
ahead.
a way where you know where it says build option change rebuilding all.
Right.
You could have, while it's saving or uploading, you could see it step by step go through. So if there's any wrongdoing in your text, there's an orange line that will show up. But that has to be in your tools or your edit somewhere.
Okay, there. Mine just finally finished up, and now I can see, and you'll have to take my word for it, that it's blinking about twice as fast as it was before.
Correct.
And what I'm going to do now, before I switch over, I'm going to change this to 100 and 100. Now I'm going to show you the difference. If I hit save, now that I went through the long compile, this time it should go pretty quick.
Yeah, which right now I'm running the 100 on mine.
Oh, yeah.
Okay, Johnny, would you like to show that? Then they'll see. I don't have to switch from screen sharing.
100.
I think John is showing it.
Okay.
And then it's easy to duplicate those lines too. If you see mine blinking, if you could see the flashing, it flashes one time real fast and then one time. So one time quite slow. You just duplicate make 4 lines.
Well, we're going to get to that, so don't jump ahead too far. Well, what you can do is you could take the on delay and you could make that like 3,000. In this case, I'm going to make it 3,000, and I'll leave the off delay at 500. If I hit save and upload.
The sequence is save and then upload, correct?
Yeah, save and then upload.
Oh,
It won't
save,
actually let you upload if you don't save first after any changes.
Correct. Okay. Yeah, it's blinking a lot faster now at 100. I did what Lloyd did. I did 100. Right.
Yep. So now I'm gonna.
If it helps, Chris, I mean, if you want to stay on that screen, I'll do the plug and play on mine so they could see, so you don't have to.
Okay, so what I did was I changed mine now to 3,000 for on and 500 for off. So it turns it on. It's going to delay for 3,000 milliseconds or 3 seconds. Then it's going to go off for only half a second. So what you have is a long on, a real quick off, and then a long on, a real quick off. So just by playing with it, you could do the opposite too. You could make a real quick flash and then leave it off for a couple seconds, and then a real quick flash, just by changing the on time to a real small number and the off time to a large number. So just by playing around with these two delay numbers, you can really change the blink considerably.
I see that. That works slick. Yeah.
Imagine on your layout, you wanted to have a tower that, like a cell phone tower with a blinking red light. Well, sometimes for the airplane safety light, it'll blink quick, but then it'll stay off longer. Then it'll blink quick, you know, they're not a steady on off a lot of times. Sometimes there's just a quick flash, couple second delay, another quick flash. So that's how you can simulate. And if you turn that number way down, you can get just like this super rapid flashing. I mean, turn both of the numbers way down to like
50.
50 and 50, and that thing will be just like a machine gun. You know?
Can you make a mistake? Is there anything you would not do on those numbers?
Not really. I mean, it's just how long is it going to be on and how long is it going to be off? So, you know, if you put in way too,
Simple as that.
if you made 3 million, it's going to be on for a long time before it finally turns off. You know? And the same thing with the number. And then the thing is, because we're in the loop section of your sketch, it's just going to keep doing those two commands over and over and over and over.
Right.
So I'm going to stop sharing for a second because I have to. I'm going to bring up the next slide or two, then I'll start sharing again. I got to remember. Okay, so I have. That's good, because I have to remember to put the slides up for people watching later on. I've kind of jumped ahead, I think, through one of them already. So that was exercise 1, upload your sketch, load and run blink. Okay. So we're going to move on to exercise number 2, which is to actually build a circuit. You know, we were just playing around right now with simply uploading to our Arduino and just using that onboard LED. We haven't used any of our components to this point in time, or wires or LEDs, breadboards, all that fun stuff that we bought. So with that, I'm going to go back out of here, stop sharing, and go to my breadboard. Okay, can everybody see this?
Mm-hmm.
Move that out in front. Looks like it's been covered. So all we really need for this exercise is a couple of your jumper wires, and we'll take a red LED and a resistor. Anytime you use an LED, you need to use a resistor with it, or you're going to fry that LED in a real hurry.
Right.
And I'm not going to get into the theory of it because we're not here to learn electronics, just to put stuff together and make it work. So first thing I want you to do is take your LED and we'll plug it in across the center of your breadboard. You see this center break in your breadboard? And I'll give you a real quick explanation of how these breadboards work in case you're not sure. If you watch my pointer, there's like 5 holes in a row. Then you have that gap in the center, and then there's 5 more holes.
Yep.
So these 5 holes going across are all connected. The next set of 5 holes are connected internally. So if I plug anything into any one of these 5 holes in a row this way, going across, that's the same as plugging them into the same as touching 2 wires, basically. The next 5 holes across this center gap are not connected to the ones on the other side. So what I'm doing is when I go ahead and put my LED in here, I'll put one leg of it is on this side and the other leg is on the opposite side. So that's literally not, they're literally not connected right now. Then you're going to take, I'll go back and explain. On the outside edge, you see a red line and a blue line, and in between that, you have 2 more sets of holes. If you look way at the top here, there's a plus sign by the red line and a minus sign by the blue line. Yep. So this whole row next to the red sign going all the way down is one connected row that you could use for positive. You don't have to, but that's just to keep it simple. That's if you always do that, you'll never get it wrong. So this whole row is all connected. So if I run a power wire into, like, say, the end hole here, you'll still have that power in every one of these holes all the way up to the top. And it's the same with the negative on the other side, the next to the blue line. So if I connect my ground into this hole, all these holes all the way up the side will be grounded. Now that's the case for a mini breadboard like this. If you get the longer one that's twice as long, and Futsky, maybe you or Dave, maybe you want to show them your two breadboards, because sometimes that line runs all the way across the entire full length of the breadboard, and sometimes it stops in the middle here. And there again, that's when you have one that's twice as long as this.
Mine has A, B, C, D, E, F, G, H, I, J, J. Then there's numbers running 1 through 30.
Yes.
Yeah,
So-
I've got mine up.
So if you look at that, and you can see, I think mine should be able to focus on there. You can see the A, B, C, D, E on one side, F, G, H, I, J on the other. So A through E on any given row, like A30 through E30 are all connected. They're all on the same, they're all connected together internally underneath.
Okay.
And then on the other side of your breadboard, you have the same repeated positive and negative. That's another strip if you care to use it. So, and it's the same as the other side. It's the red is all powered all the way up. The blue is all.
Hey, Chris,
Now, why
Yeah.
does Dave have jumpers across his?
in
Yeah.
my case here, can you hear me?
Yeah, Johnny, want to show us?
Can you hear me? Okay. In my case, on this particular board, I've got jumpers across here because you can see the blue line is broken. And on the other side, the red line is broken. And the same over here, the blue and the red line are broken. That means that this particular board, they run the power only halfway across. And so I have jumpers to carry the power to the other side. On this other board here, though, notice that the blue and the red line continue all the way. So they run those run the full length. So this is basically two different boards, one where it's split in the middle and one where it's not. That's all the difference there is. But it's a caveat that you got to kind of watch for, because otherwise it'll trip you up. I guarantee you, it tripped me up at first. I didn't notice it, and I was wondering why I wasn't getting power on the other end of the board.
Oh,
All right, thank you, Dave.
so where are we
So-
going to put these LEDs then?
So I would pick any row. You know, I just happen to put it in 16, and I put one leg on.
Which leg? Short or long?
I'll have to pull it out and look. And I was going to get to that. We can find it. If it doesn't work, we just flip it around. So I happen to put the long side on E and the short side on F on the other side of the big gap in the center here.
Yeah, short leg is ground.
Right.
Well, that's why I was asking, yeah.
For everybody. Chris, I tell you what, on these LEDs that have a plus and minus, I saw just the other day somewhere where somebody was showing, take a black marker and mark either the positive or the negative. Do that the same on all your LEDs. Either mark all the positive with a black marker. That way you won't get them mixed up. You'll know which one's positive and which one's negative. That might help everybody too.
Okay, thank you. Also,
There's also one other way to tell. If you look, there's a flat edge. You know, that's the LED is normally circular, but there's a flat edge next to one of the wires. That flat edge, I believe, is the ground.
Yeah, that's usually the negative. Okay, so going back to mine now. If you see, I now added a jumper wire. And actually what we should do before we go any further is unplug our Arduinos.
Unplug them?
Yeah, unplug it so it's unpowered.
Oh, okay.
Since we're going to be poking around in making connections, and in case we make the wrong one, we don't accidentally try something.
Now, where do you plug it in the Uno Which hole?
Remember, if we go back to the blink sketch, if you remember, it said that there's an internal LED on most Unos, and it's on pin 13. So what we're going to do is go to my screen up here so I can make sure I see what I'm showing you. I actually went into pin number 13.
13, yeah.
Which is up on the top here. So what I'm going to give you another quick sidebar here. Back in the beginning, remember I was talking that this thing is basically an Uno or an Arduino is basically an input-output device that can be programmed to do different things depending on the input and the output that you want to do. But there's also the number of pins. Like along this whole top side, most of these, you'll see it says digital. These are all what they call digital pins, and they're basically on-off pins. But down here in the lower corner, you see some that are marked A0 through A5. Let's see if I can put that in. You can see right down here, they're A0 through A5. Those are actually, okay, I'll try and hang on for a second and we'll jump out here. Those are called analog pins. And what they do is they're not just on or off, they'll actually allow you to have a variable amount of voltage. Kind of like an old rheostat or something, you know, they can actually sense different amounts of voltage and adjust accordingly. Where a digital pin is pretty much strictly on or off, as far as I know. The analog pins are more like a dial on your radio. They can, you know, adjust it in or out. So my audio is still bad, Johnny? Okay, so if you want to switch to somebody who's working with something while I do a quick refresh here.
Yeah, the mute just doesn't work, does it? Okay, in my case, I have also on pin 13, I'm running this, it's actually a green wire, it kind of looks like a black one. I've got it connected on this side of the breadboard here to my resistor, which is jumping over the gap. Instead of Chris, he had his LED jump in the gap. I tend to like to put my resistor before the LED, and it's connected in. In this case, this LED is a RGB. It's red, green, blue LED. So it's got 4 legs on it, but I'm just connected to the red leg right now. It's jumping up and coming over here, the ground. And then I'm using this whole ground rail over here. And the ground line comes right back. And there's a ground pin, a place to plug in your ground pin right next to number 13. You'll see it says, correct, the G&D label. There's also a couple of ground pins you can connect to on the other side of the Arduino right next to the analog pins that Chris was talking about. They're like right over here. There's 2 of them right next to each other. And you can plug into any one of those over here or over here if you want to.
Okay, I got to back up here.
Oh, Chris is back
I
up.
got to back up. No, I need you to back up. You've got, you don't have your LED in the center. You've got yours on the plus and minus side on there.
Correct. I don't have mine on the center. That's because I like to put the resistor before the LED. And so I'm running the resistor first, and then that's, you know, that reduced voltage is driving into the LED. The reason I put that first is in the event of some sort of a catastrophic failure or whatever, you're more likely to protect the LED because it's gone through the resistor first. Right.
And we all know how expensive those LEDs are. So.
Oh, I know, they're horribly expensive. Yeah.
So which does it matter which number you're using on your plus minus section there?
Over here, the actual rail
on
number.
Your plus minus where LED is plugged in. Doesn't matter which number you're at.
Not really.
All right. Well, I tell you what, let's get back to putting this together,
trying
and
to
we'll use Dave's theory.
Go ahead with
So
your
just
question.
Well, he wants to know exactly which number to put it in, so just to work along with us. So
But we all do
Right.
it the same way. So we,
right, that's
Um,
why let's just stop and reclock here. We're kind of getting off in 6 different directions at once. So let's just go back and we'll use Dave's. I like Dave's idea. So we'll go into row 15, and you can run your diode or your resistor, I mean, across the gap on row 15, like so.
What size resistor are we
Everybody see
using?
I'm using a 300. You can use anything from like 220 to 1,000. You can even go higher if you want to dim your LED. The more resistance, the dimmer your LED will be. But the value of the resistor can vary depending on the voltage, and that's getting too complicated. But just as a rule of thumb, 200 to 1,000. Typically 300 or 400 will be the sweet spot, somewhere from 300 to 470 for a normal brightness LED on anywhere from 3 to 9 or even 12 volts. So I'm using a 300.
I'll speak.
What's that?
I'll speak for the ignorant. The longer is the power.
Yeah, I lost him completely. So I think he was saying if he's talking about the LED, the long is positive. So going back to this, and we're really making kind of a mountain out of this, but I want to teach some little bit of theory as we go. You put the resistor across the bridge, okay? Then you connect the long leg of your LED to your power, and the short leg to the ground. Or Dave, do you put the LED?
No, that was correct.
Okay,
Short
so
leg is ground.
So we're gonna put the short leg in row 15 on any other hole other than the one the resistor is in, and then put the long leg.
I would run the short to the ground rail, to the blue rail, and then I run the positive to the other end of the resistor.
Oh, okay. That's what I was getting at. So you're putting the long leg in row 15 and the short leg
Yes.
in the ground or the blue rail.
A little hard to see. It's a little bit blurred.
Okay, so the row number isn't really relevant as long as you stay in the same row with your LED and your resistor, and you put that gap in the middle.
Oh, like that. Okay, now I see. All right.
Yeah.
All right.
So what we're doing, and let me just throw the wires in quick, and then we'll show you how this works. It'll make a whole lot more sense if we just finish it up. So I'm just going to take the ground wire. Oh, I got me the wrong wire. That's a male to female, and you need a male to male. My wires mixed up. And that's also the wrong one.
You guys may notice that Chris used the red wire to represent the power coming into the LED and a black wire going into ground. Kind of recommend using, color coding the wires that you use. Red, of course, for positive in many cases. If you're running different color LEDs, you might want to use a red wire for a red LED, yellow wire for a yellow LED, green for a green one, and black, of course, for ground.
Yeah, makes sense.
Okay, so what I did, as you can see, I'm now blinking for 3 seconds and it'll go off for a half second because I left my sketch with those numbers 3,000 and 500, which is where the last place we left off. But basically all I did was, if you look at this, think of it as a complete circuit. Pin 13 is where the blink sketch is saying send power high to pin 13. So we plugged in our positive into pin 13 on the Arduino board right here. Then I just ran it over to my breadboard in the same row 15 that my resistor is in. So the power is going from the board, from the Arduino to row 15 on this side. It's coming across the resistor and then to the LED, because I have one leg of the LED in row 15 and the other one on ground. So then I just hook the ground wire back to the Arduino. So it's basically just the electricity is flowing in a circle. Coming out of the Arduino, going through the red wire, through the resistor, through the LED. And if I actually move this back over here, it'll look a lot better and make more sense. Oops, if I put it in the right. And then back to the Arduino. So it's just basically 2 wires, a resistor, and LED. And now we're doing the same thing with this LED. And you can see the little one on your board where my pointer is still doing the same thing too. So now we have both of these flashing the same. So now we have an external LED doing the same thing the internal LED was doing. Is everybody able to do that so far?
Sure, you got the correct number, right?
Yep. Anybody not able to get it yet?
Well, I'm still working on it.
Okay.
Ready LED is in pin 15, blue side, the negative side.
Right.
And then that
So
goes, the short end goes on hole 15. The resistor is in hole 15 on both sides.
Yep.
Okay, that I'm far that far. Now, your cables, your
Yep. You run a power from the side of the board opposite where your LED is. And it can be right in row 15, right along with your resistor.
That's I've got mine right there too. Okay.
And then it goes to pin 13 on your Arduino. Closer so you can see it better.
And is that on the digital side?
On the digital side, so it'd be digital 13.
Okay. And then the ground?
And then the ground, right next to ground, 13 is the one that actually says GND, that's a ground. There's also 2 of them on the other side here. You could use either one of those if you wanted, as far as I know.
Yep, ground is ground. It doesn't matter which one you use.
Does it say ground on it or what?
Yeah.
Oh, ground. I see it now.
Yeah.
Yep. Yep, I see it now. I couldn't see it was above the numbers. Okay, very good.
So that's basically it.
Okay, do I plug it back in? Do I dare plug it back in?
Yes, absolutely.
Watch her blow.
That's what we want. Let the magic smoke out. There's no such thing as electricity, I was told. Only magic smoke. If you don't believe it, let the smoke out and see if it still works.
Hope I got it in the right pins. That's the other question.
Yep, I see the LED flashing on the board, but I don't see them, on the Arduino itself, but I don't see it flashing. So. I think you might be right. Well,
okay, which row are we not supposed to? It's in hole 15.
Actually, I think the LED is not in the same row as the resistor.
Yeah, that could be.
Unless the resistor is not all the way in there.
It could be.
And that might be possible. Tell you what, why don't you just grab 15, that 15. Why don't you just grab that lead out of the resistor and touch it to the leg of the LED and see if it goes on for you.
Which leg?
The one where
the one on the LED side.
The pins, next to the pin, or where it's lined up there.
The LED side?
Not the ground one. The other one. The other option, the other possibility is the LED is in backwards.
I just took the whole thing out.
Okay, yeah, you should get that resistor. It looks like the red wire and the LED are in the same row, so you should be able to get the
Yeah.
resistor across that same row and you should be good. Sometimes you need a magnifying glass, so don't feel bad. I take my glasses off and get up real close usually.
No, that's the other thing. I'm kind of working a little bit in the dark here too. That doesn't matter. I can see what I'm looking at. Unless the
Well, then you do
LED's
better
not in
than
there
me.
all the way. Yeah, everything's plugged in. Okay.
Double check that your red wire is going to pin 13 in the Arduino.
No, 15 I'm using.
Oh,
Oh, you got to use
15
13.
there.
Oh,
In
you
the
got to
Ar-
use 13?
no,
Well,
in the
13 on the
Arduino
Arduino.
itself. On the Arduino board is 13. On the
Yes, it
breadboard,
is.
it's
Yeah.
15. Okay.
Yeah, it's in.
Okay.
It's in.
Yep. Try
Oh,
turning
that's a
the
good
LED.
point. Okay, the long leg is in the on the side of the blue line.
Yep.
No, it's a
Oh, yes.
short leg.
I'm sorry.
Yeah.
There you go. Johnny's right. Now I got to find 15 again. Like I said, it's a little bit dark here. And there we go.
All right.
Johnny, you're my man. Thank you. That's all it
Okay.
was.
So now we're gonna have some real fun.
I should know that. That part I know about LEDs. That's my kind of my fault too. Thank you.
Okay. So I'm gonna go back to sharing my screen.
Okay.
And just for fun, I'm gonna show you the slide that we skipped over. We actually did it, but we didn't look at the slide. That was to modify it on time, off time, and delay. So we kind of did that already. So now we're gonna do a little more editing to the code. So what I want you to do right now is just unplug your Arduino for a minute, or you can leave it plugged in. I guess it doesn't matter. Go back to your Blink copy that you saved. Now, if you want, you can either just continue to edit this one, or you can do a save as and start a new sketch. It doesn't matter. It depends on whether you want to come back and play around with this again later. I'm just going to go ahead and continue to edit this same sketch. But I'm gonna show you how simple it is to make a big difference in your Arduino without even having to really know how to program, other than those couple little things that we figured out before about changing the time. Inside this void loop, okay, we have these 4 commands that are basically on delay, off delay, on delay, off delay. I'm just gonna take that, highlight it, and copy it to my clipboard, or Control C, or if you got your mouse, just right click and copy or something. But by copying that to my clipboard, then I'm going to move down a little bit, 1 or 2 lines, then I'm going to paste it in. Okay, I have another, this is exactly what Andy was referring to earlier, and now have that same command in there twice. If I loaded this right now, you really wouldn't see any difference, because on for 3 seconds, off for half a second, on for 3 seconds, off for half a second. Well, that's what it was doing anyways. But what you could do now is go ahead and change a number, go down to this copy we just put in, and I'll make that 1 second or 1,000. And I'll make this one 2,000. Just picking numbers out of the air here. If I go ahead and hit save and upload, and now it might take a little longer because of the change in code again to compile it and upload it. Changing more than just a number, I actually added some lines of code now. So, and this is a kind of, while we wait, this is kind of a trick you want to learn, because you're going to start to say, hey, I know how to use LEDs and I know how to use a sensor. How do I put them together in one sketch? Well, just copy and paste the correct sections out of one sketch into another, and you can actually combine sketches that way. So now I'm going to quick switch back. I have that uploaded successfully. I'm going to, oops, too many windows open here. Anybody else ever
We're
have
gonna
that problem?
copy and paste
Of
this,
course.
right, Chris?
Yep, copy and paste. And then change the values in the section that you pasted. Now, if you look at mine now, you're going to see
Yeah,
that.
but where am I gonna paste? Where am I gonna paste it to?
Oh, okay. If you were right below the last, hang on one second. I'll come back and show you. I just want to show what happened here on mine while I stop
Good.
sharing. There we go. Okay, so now you're going to see it's going to go on for 3 seconds, off for half a second, on for a second, and then off for 2 seconds. So you no longer have a steady, consistent flash. You have a long on, short off, short on, longer off. As you can see, it's not just blinking a steady pattern. It's a pattern of 2 different series of blinks. So what you could end up doing, and I'll go back to the sketch now and start sharing, and we can help out Boy. And then I'll come back and show you. Oh, yeah, if you have some on there. Okay. Okay.
That's cool.
There we go. So can you see my sketch again?
Yep.
Okay, so what I did was right underneath this last delay is
Yep.
where I just put an extra space in so that you could see where, and then I pasted those 4 lines in. Now the trick is, you see this on the very last line, there's that little bracket. Make sure you're inside of that bracket, otherwise the code
Inside the
doesn't work.
bracket. Inside the bracket. Okay.
Yeah, make sure that bracket is the last thing in your code.
I'm trying to get inside the bracket. Oh, there we go. And then paste.
Yeah.
Okay. Very good.
So
Okay.
now I'm gonna change my code one more time. I'm just gonna go 1,200, 1,000, and 3,000.
Or whatever you want to put in.
All right, whatever you want. What I'm going to show you this is going to do is going to be basically 2 rapid flashes and a pause. 2 rapid flashes and a pause. Because it's going to be on for a second. In fact, let's make those 500. Well, I already have it writing, so.
Okay.
But it's on for a second, off for just 2/10, on for a second, and then off for 3 seconds. So it'd be like a double flash, wait, double flash, wait, double flash, wait. You know. Okay.
Oh boy! Now I got a thing here. It says a function definition is not allowed here before T token or something token.
Okay, so you might have pasted into a bad place.
Yeah,
Or
I
got
bet
one
I
of your-
didn't have it pasted in that bracket you said. I thought
Can
I
you share
did.
your
But,
code? If you share your code, I'll
I don't know if I can right now. I'm working on two computers here.
Okay. So what I do while we're working on this is go back and just open a fresh copy of blank, and then do a save as again,
Okay.
and then copy and paste. And when you're ready to copy and paste, I'll show you where. Just
I
So
bet what
if you-
happened was he may have pasted in after that closing bracket.
yeah.
I thought I had it within that closing bracket, but evidently there wasn't enough room to get my cursor in there or something. I don't know. How about if
So
I
if you
go
look
back?
at-
How about if I go back to the blink? My first blink I saved, the first one I did. Can I
Yep.
do it in there?
Yeah.
Let's see if I can paste it in there. Should be still there, right? The paste.
Sure.
Yeah, it is.
You got all 4 lines, and just put it immediately after the 4th line. if you take a quick look at mine, Johnny, if you want to share that one. Okay. Okay, I haven't seen it, so I've been seeing somebody else's. So, but yeah, it's just it'll flash, off, flash, and then a long pause, on, long pause.
Okay. And then if I type, after I type that in, the change in, what do I do again? No, just it's save and then upload, right?
Yep.
Okay, save. Save. Whoops. Crap. You know what happened, of course. I saved it on my computer, not into the Arduino. Go ahead. Go ahead. Just continue on. I got to go back.
What we're gonna do now. Yep.
With this question. Hi, Chris. Got a question for you from Lynn A. I have a MacBook Air running OS El Capitan and could not download the drivers to the Arduino. I know Dwight's probably got the same one, and you want to explain that later to Dwight towards the end of the show how you did, or does it take very long to explain?
He goes right to the Arduino website and download where it says daily builds, nightly builds, and click on the Mac upload for nightly builds. It'll give you the 1.8 something night for that evening, and that's what worked for me.
Okay.
Okay. Otherwise, we'll connect after the show.
Yeah. Hopefully they'll help Lynn out there. Yeah, Lynn, you can email Chris if that doesn't work, and he can help you offline getting that loaded up. Back to you, Chris.
Okay. So we're gonna go on to right now. If you want to do a little, we can either do a little quick show and tell where we each change our delays and our make some random blinking patterns with the two different sets of code. Or if you want to keep moving on, we can go ahead and add some new LEDs to the project. Okay.
Okay. Okay, you could see that on mine, I kind of, being the programmer that I am and a little bit more familiar with programming, I've got mine blinking SOS.
Anybody else want to share? That's pretty cool. Hopefully people on YouTube land are having some good luck following along this. I know this is going kind of slow, but we're trying to learn to put the building blocks under us. We'll get to more work and less.
Your audio is bad again.
Okay.
I'm just running mine right now with on for 2 seconds, off for let's see, 100, so whatever that works out to be, and then back on for 2 seconds and off for 1 second, and seems to be working pretty well.
Are you there?
Yeah, I'm starting over because I put it in the after that bracket I didn't put in the right place. So I went back to the original sketch, the blink one, but I can't find the bracket now. It doesn't show up.
I would just
Yeah,
I would start with a brand new just blink from the exercises.
start with a new blank.
Yeah, brand new blink and do your save as. Give it a different name. Now you know it's a clean, fresh copy.
Sure. Well, that's good to know because that's probably what. Oh, now there's a blink there though. I mean, there's a bracket there. I can add it to there, can't I?
Yeah. Before the bracket.
Before the bracket. Okay, it's blinking before the bracket. Now, if I wonder if I click paste, if that'll put that still in there, let's see what happens.
All right, so in the meantime, I gotta go.
Save.
Okay, I'm just running the 1 second off for 2/10, 1 second back on, then off for 2 seconds.
Oh, yeah.
Still didn't.
Yep. So that's kind of a neat way to just be able to change from a steady blink to a pattern. And of course, you can absolutely make more copies of that. So you could do like Dave Heili did, was, you know, make a pattern of 6 different flashes by copying and pasting 6 times and changing the values in each. All right, how's it now? Any better? How's my audio now? Is this any better?
I did find out I can actually, with the 1.8.1, I don't have to save it. All I do is upload it, it automatically saves it.
Oh, it does?
Yeah. But that's what, I don't know if maybe that's just my version of the Arduino, because I know the other night somebody was running 1.80. I've got 1.81. So.
All right, so I'm gonna get moving on here. We can always come back. I gotta reopen my slideshow. We lost it when I rebooted. So what we're gonna do now is this sharing. Oops. Okay. Right now? No. Okay. There we go. So now we're going to move on to exercise 5, which is to build a circuit again. What we're going to do is make another copy of the red LED and the diode.
Okay.
So I'm calling this add second LED and resistor to your breadboard. So first thing I would do is unplug your USB cable, just in case you plug something in accidentally in the wrong place. And then go ahead and start putting in another resistor and LED in another row.
Any color you prefer?
And I'll show you in a second. I'm just going to explain these so you can get started, and then I'll get out of sharing, and you can watch as I build it quickly. And then
Colors?
red LED, another red LED.
Okay.
So let me stop sharing, and I'll.
On a resistor installed, does it matter which way they go?
No, does not.
No, resistors don't matter.
Okay. I couldn't remember. The last time I had electronics class was like 30 years ago.
Well, if you've ever installed a decoder in a locomotive.
Nope, never have.
No.
So I was in row 15 before. Now I'm going to put another one in row 10. It's the same thing. I'll put the short leg in the ground, the long leg in row 10A. Then I'll take a resistor, jump across row 10 from one half of the board to the other half. Sometimes I think it'd be a lot easier to just clip some of these legs shorter, because once you use them once or twice, they get kind of flimsy.
Yeah.
And now I have to make one change to my breadboard. Before I had my positive going right into the row with the resistor, I'm going to move it out into the red row the long way now. And then I'm going to need 2 more wires. So now I have to add power back to the first LED. So I just taking this orange wire, connecting it from the red row of power to row 15. Then I'll take another jumper and do the same thing. I'll go from power. Actually, you know what? I'm going to do this a little different. Disregard that. Put your power back into row 15 where your first LED was. Because we're going to actually operate the second LED we're putting in off a different pin now.
And the resistor is going also on row 10.
Correct. And then I'm taking a jumper wire now from pin 12 on the Arduino, or heck, I'll make it 10 just because it matches. Okay, so now I'm going from pin 10 to row 10. Everybody
Well,
got
you
that?
got big thumbs, I'll tell you. This is fun. Oh, God.
So what we're going to end up doing is driving this second LED we just put in from a different pin on the Uno.
So all that code we copied and pasted, can we delete that out then?
Yeah, I think we'll just start with a fresh copy of Blink. It'll be faster and easier. So if you have your all wired up already, go ahead and go open up a fresh copy of Blink.
Well, hold on.
And I'll share my screen so you can see how I do that. Okay.
Shoot. there's nothing to do.
Getting back to our jumper wires. We're going to leave them in 15, did you say?
Yeah. The original one that's on pin 13 of the Arduino can go to your row 15, wherever your original LED was.
Okay. Gonna leave the original LEDs in there?
Yes.
Okay.
Yeah, we're adding a second one now.
Okay. 10, 10 all the way across, and the jumpers are in 15. All right.
So I'm just going to go to File, Examples, Basic, Blink. That's where we found that.
Files,
Okay.
examples, basic, blink. Okay.
Yeah,
Okay.
and I'll expand that. So now we have a brand new fresh copy of Blink. I'll just quick do a file, save as, and I'll call it Blink 2 LEDs.
Save as blink LEDs.
Yeah, or 2 LEDs.
Well, yeah, apostrophe S. That would.
Mhm.
Okay.
And now
Okay.
we
Save
can-
that.
Yep, and we can do exactly what we did before. We'll copy these 4 lines of code.
Okay. Now we got to back up the West. Make sure I do this right now, because I screwed up last time.
All right, so starting at digital right, LED built-in high.
Maybe that's what I did wrong. Maybe I didn't copy it correctly.
So those 4 lines of code that are in kind of an orangish color
Yep. Yep.
that I have highlighted right now.
Yeah,
Copy
that's what I
those.
got.
Don't copy anything ahead of that or behind that, just those 4 lines.
Okay.
Then move your cursor down 1 row, or actually 2, without going past that little bracket that's on the end. See this very bracket at the end?
Yeah, yours looks different than mine. Mine has a different, might probably have a different typeface. That's probably why.
Well, you're on a Mac too, aren't you?
That too.
Yeah, okay. So then when I'll paste that in.
Wait a minute, back up. Work. Sorry. I didn't see where you put it.
I just put it here. Here's the end of the original code. All I did was move down 2 rows and paste it in just to leave a space in between here.
Oh, I thought you meant in front, either behind or in front of the bracket itself.
Well, the bracket is still down here at the bottom. The very last thing in the
Right.
code.
Right. Where am I going to paste?
So let me just delete this and show you. It'd be a whole lot easier. No, I didn't catch it all. I'm sorry. So this is what you should have had. So right after that, this was the 4 lines of code we had highlighted. So
Yep.
all I did was put the cursor down 1 row.
Yep.
And then I hit enter to add a second row just to give a space and then paste it in. Oops.
Okay, the problem with me right now is when I did that, I don't have a row. The brackets right away is the next line.
Yeah, let's just hit enter and add a row. If you hit enter, add a blank row.
Hit enter again.
No, that didn't work. Yeah, probably.
Okay, so while he works through that, I'm gonna go back up here, and there's one more thing we have to do now. If you look up here, this says pin mode LED built-in output. Oh, you know what? I have to apologize. I kind of screwed this all up. I need a different sketch. Unless Dave would know off the top, or Andy. We need to define. We need to define pin
your
13 and 10.
Yeah, you got to define. Hang on, give me half a second here.
If you can find a sketch that has that, because I don't want to teach these guys to have to write it. I want them to show where they can pilfer it from.
Well,
you know,
all you have to do is change the word LED built-in to 13.
Okay.
Okay.
So if you just change every time it says LED built-in, you just put 13 there, you get the exact same results you were getting a minute ago. LED built-in is just a built-in variable. It just means 13. Just take it as it means. So, and then if you want to add that additional one, you just have a 13 and then a 12 or whatever.
So, but we have to define 10 also now. So would you do same thing, pin mode 10 output?
Correct.
Yes. 11, 10, and 9 are slightly different. So I would do like pin 8, for example.
All right.
That's far enough away and it's down there easy to get to. I did 8, 12, and 13 in this little one I'm playing with.
Are you worried about the PWM on there?
But as long as you set it to, well, 8 is
It's not PWM, is it?
no, 7 starts PWM.
Correct.
So
By the way, I did figure out what I did wrong here now. I got what you want me to do, Chris.
Okay. So if you can see what I did here, up on that first row, it said pin mode LED built-in output. I erased the LED underscore built-in and put in the number 13. Then I copied that line and pasted it right below it with a second copy of that line. So it says pin mode 8 output. All it's doing is it's telling the Arduino that pin 13 is an output instead of an input. And the same thing with pin 8. Then we have to come down below here and where it said LED built-in, make that a 13. What you're doing is you're basically naming the pins, and then in the code here, you're telling it which pins to turn on and which pins to turn off. So if I'm doing this right, and I'm not 100% sure that I am, I'm winging it too, like the rest of you guys.
Yeah, you're doing good.
So in the first set of turning on and off the LED, we make it 13. So it's telling it to turn pin 13 on, then turn pin 13 off. Then it's going to say turn pin 8 on and turn pin 8 off. So we have an LED on each of those pins. So if this works right, it's going to turn on the first LED for a second, turn it off for a second. Then it's going to go to pin 8, the second LED we just put in, turn it on for a second, turn it off for a second. Then because we're in loop, it starts all over again. 13 on, 13 off, 8 on, 8 off. And just repeat that for eternity. So first thing I'm going to do is hit verify or save. I should say, save your sketch, and then go ahead and hit verify, just to make sure you didn't, because of all the copying and pasting, it's not a bad idea. It'll test to see whether you got outside the brackets or you typed something wrong, got rid of a comma where there should have been one. It's easy to do that kind of thing. So while we wait for it to compile, I'm going to actually stop screen sharing so we can see what happens on my. It was figure out where, there it is. Stop. All right. I haven't uploaded yet, so you're still seeing that goofy random blinking pattern I had before. But now it's still compiling, so I guess we got to wait just a little bit.
Okay, I did have a question here now. When it said pin mode 13 output, I didn't have the word pin mode 8 on the bottom of mine, so I typed it in.
Yeah, I just did what I did was I copied that whole line, pin mode 13 output and the semicolon, and I pasted it in right below there, and then I just changed the 13 to an 8.
So now I changed it, and it was, as soon as I typed the correct the capital letters and not, it turned right away to red. So now it says pin mode bracket 8 comma output. So output should be in capital letters though, right?
Yeah, and then a semicolon.
Yes, the output does need to be in capital letters.
That's why I copy and paste, because that way you know the formatting is right. You know.
Would you say a semicolon after?
Yeah,
output?
just like the line above it.
Yeah,
That's
you need
why
a
I copy and
semicolon in
paste the entire line.
Maybe Chris, here, why don't you give me just half a minute? We'll go through some of the normal syntax of.
Well, no, I don't want to get into too much programming. I want to keep
Okay.
this simple. Just teach them how to copy and paste and not have to learn what everything means. You know what I'm saying?
Very well.
One quick question: the semicolon goes on both the word output, correct?
Yep, it's just same way it was on the original line.
Yeah, I'm there.
Okay. So mine got done compiling. I'm going to hit verify, and it actually, that's what it did. It compiled the sketch, and it didn't bomb. So as soon as it gets done doing that again, I'm going to upload it to my Arduino. Yeah, that's why I just want to teach these guys how to copy and paste and change a few numbers. If you get into typing your own, then you're going to have to learn all those correct things to do. That's why reinvent the wheel? Just copy and paste. And then change a number or two. That's all we really have to do to accomplish what we're trying to do.
I was just thinking it might be a little bit helpful in case somebody finds themselves in a bind where they don't know what's wrong.
Right, but then if you want to take the deep dive, then that's what the internet's for. We want to keep this just a simple kind of hands-on. If you want to take it further, you're free to, but at least this shows you that it can be simple. That was the whole
I bought
point.
the book about all this other stuff you're talking about. I'm sure I'll figure out what I'm doing wrong anyway, but
you know, copying, pasting is simple, and just changing a number, having to understand what needs to be capitalized, what didn't, what needs brackets, what needs colons, you know, that's farther than I want to take this. I want to just teach how to copy, paste, and change a few numbers and accomplish without having to understand everything. All right, so I'm going to upload now.
One thing I noticed when I did this is the first LED that I already had plugged in is brighter than the second LED that I'm running off of pin 8. Any ideas why? I'm using the same kind of resistor for both.
How much brighter is it? A lot brighter, or just a?
Yeah, it's really quite a bit brighter. I don't know if you can really see on mine or not.
I've run across that problem before. Check that the pin number in the sketch, which is, it says pin mode 8. Check that your wire is actually running into hole number 8, because if you're running into hole number 9, it'll go on just really kind of weak, a very weak thing.
Well, I just figured out what I did. I had put in a different pin to start with in the pin mode, and I just noticed that. So
Yep,
my
that'll do
fault.
it.
My fault.
Yep, that'll do it. You kind of got to be careful because if the pin mode doesn't match where the wire's connected to, then it's just a really super weak color.
Yeah, well, Chris had mentioned going to 12 originally, and then he changed it to 8, and I had already put in 12 and then forgot to change it back to 8.
Yeah.
Yeah,
Okay.
see, like
So
with
if you
mine,
look
I
at,
didn't realize mine were diffused. That's why mine's dimmer.
okay, if you look at my sketch now, you'll see that one LED goes on, then the other LED goes on, and they just keep going back and forth. Now that's perfect for a grade crossing. All we really did was, you know, I could duplicate. If you had two LEDs mounted in a little cross buck, here's your flashers for, now if I want those to flash a little faster, I'm just gonna go change a couple values on my, I'm gonna shorten
Unless
each
you want to bring
one
my
to about,
sketch up, you could see I've got it running back and forth. It's probably a little more appropriate for a grade crossing.
yeah, go ahead, Johnny, if you want to put him up. So mine started with just the base values from Blink, and now I'm just editing some values while Dave shows you his, and in a short time, mine will change. All I did was change all the 1000s to 700. I hit save, upload my sketch, and very shortly it should start flashing in a different sequence. Just faster, that's all. So it looks a little bit slow for a railroad crossing for me right now. And as soon as streaming must be taking a lot out of my processor because this just takes a lot longer than it usually does.
Oh yeah, I can hear my fans running on my laptop. But it's hot.
Yeah. So now there's a little bit of a difference. You can see that it's a little quicker, but still not fast enough. I don't think it's close, but think about the railroad crossings you see. So let's try, okay. That's looking good. Who else wants to show theirs? I like the two colors. And as you can see, because he's still on pin 13, you see the one on his board is also flashing.
Oh, Andy's.
And that was the one. Yeah. So what I was going to do, and I don't think we're going to tonight just because we're just about out of time, was if you take this same principle, add a third LED to a third pin, and then just make a third copy of those on and off sequence. And if you use a red, a yellow, and a green, you could make your stop and go light. All you do is add a third of each. You know, we started with one, we added a second LED and a second line of code for each. If you do the same thing, just copy and paste the code one more time for a third LED and physically install a third LED and resistor. By using a red, a yellow, and a green LED, you could have a traffic signal. Okay. All right, so now we're back showing mine, and I'm going to just cut the time down on each. I'm hitting save right now in my sketch and upload. And hopefully in about 10 seconds, you'll see that it flashes even faster.
Yeah, I switched the time on mine to 250 for both LEDs, so it's blinking quite a bit faster. Looks more like a grade crossing, maybe.
Yeah, I just dropped down to 400 to see what would happen. And it's just about done compiling. It should uploading. Okay, looks good, Ken. Nice and, yeah. So that was at 250, Ken?
Yes, 250.
Okay,
Yeah.
now if you look at mine, I changed mine to 400 now. So there's the difference. If you look at Ken's a second ago and look at mine now at 400. That's not too bad either. So somewhere in between 250 and 400, I think looks pretty good for a grade crossing. So now you go buy yourself an old plastic Bachmann cross buck and grab, super glue a couple of these LEDs on there and impress your friends with your new Arduino activated grade crossing. And it's really, I mean, we spent an hour and a half, but we cover a lot of ground. You can really throw this together in 10 minutes. I mean, it's that.
How long of a wire can you run to a grade crossing from something like this?
Oh, I would think as long as you need to. I mean, use some Cat 5 cable or something. It shouldn't be too big in a deal.
Yeah, but 100 foot or something's not going to have a tremendous amount of resistance in it. If anything, the LEDs might be slightly dimmer, and if that's true, just lower the value of the resistor you use.
So what I'm going to do real quick here is just unplug my Arduino, and I'm going to swap out a red for a yellow. All right, I'll do the green, and we'll pretend that this stoplight has no yellow. So I just pulled out the red. Now I'll just plug my Arduino back in, and you see these goofy flashes. That's just the Arduino booting up. Then all of a sudden it should go to flashing there. Now we're flashing green and red. So just a real quick change to the code. I go back and I can make the red one stay on for like, I'm going to make it 5 seconds, even though in real life it would be more like 10 minutes. Ask anybody who sits at a red light. It's always 10 minutes, isn't it? Well, you know what I mean. Seems like 10, doesn't it? Then I'm going to make the delay, oh, just real quick, like 100. Then on the yellow one, of course, the green always seems like it's only 30 seconds, but that's probably 2 minutes also. So I'm just going to make that one 5 seconds also. And then back to 100 for the off delay. And I'll just hit save and upload. Done saving and now compiling. And as soon as it finishes uploading.
For me and some other clowns like me, the hardest part is going to get this code correctly on the panel that we're working with. Exactly where your blinker goes, how to copy and paste things in the proper place.
Yeah, if you read the best thing that, and the way I kind of learned quickly was reading through sketches and trying to understand them before I ever built them.
Yeah.
Just try it, and you kind of learn that. One thing I learned is, okay, everything kind of needs a name. Like each pin should have a name, even if it's just the number of the pin. If you notice in Blink, they called it built-in LED or whatever it was. Okay, they could have just called it 13. You know, so you could call it red L. Right, but every pin needs a name, and then every pin needs to be told whether it's high or low, or whether it's, I mean, I should say whether it's an input or an output. So you give it a name, and then you tell it whether it's an input or an output, and then you can tell it to be on or off, you know, by name. If you called the name, if you called the pin Lloyd,
it'll say decals instead of decals.
Yeah.
So if we did add a third resistor and a third LED, could we put it in pins 0 through 7, or are there certain pins we can only use?
Yeah, you can use, I think, I mean, and there's an Andy question, but pretty much any of the digital, some of them can, those ones with PWM can do a little more than, you know, Andy would say maybe to avoid them, but I think you can use them as a straight input output, maybe not. But
You could use them as an output. If you have 6 or less LEDs, you're better to use 8 through 13 because the PWMs come with you know, at some point we'll get to, you know, D-big LEDs and you could, you know, put the appropriate code to deal with the PDM outputs. So for right now, I'd stick with the 8 through 13, but there is a way to use the 2 through 7.
Okay.
8 through 13.
Right, and that just I mean, just plain basic. Now I understand. Okay, if I'm going to do LEDs, use only 8 through 13. I mean, that's perfect. I mean,
yeah.
Okay, that's what I need to know too. Right.
You could use the PWM boards, the 2 through 7, but after a few shows, after we've talked about D-big LEDs with PWM, then we could talk about the setting where you set the PWM to stay constant. It'll make your life easier if you just wait till we get there.
right. No, I understand.
So Johnny, I don't know who's you're showing right now, but if you show mine, you'll see that it's now just doing a shortened version of a stop and go light without the caution. You know, it's red for a while, and then just adding that third LED, then you know, it's green, and it could go yellow and then red, and different amount of time for each one. And it's really that simple. Just 3 LEDs, 3 resistors, a little bit of code hacking, and you're done. Don't have to write the code, just copy, paste, and change some numbers. It's all you have to do. So that's 2 things that we learned tonight that you can apply to your railroad. You could do a crossing button, do a stop and go light. You could do little blinkers, like I said earlier, a double blink or a real quick blink with a long delay for some kind of a cellular tower or a water tower flashing light. I mean, any kind of, you use the same concept now. You can blink any pattern, any number of LEDs for whatever purpose you want to do with it. So
From a practical application, how would this be installed on a layout then?
well, you would take either the whole Uno, or you could go buy one of those little Pro Mini Unos, and just because there's only 3 wires coming off the Uno, why would you need anything more than a little mini? Just solder the 3 wires onto a mini.
Mm-hmm.
Also, a really handy thing that we got in these kits is these little proto shields. So
Yeah.
you could once you've got your circuit designed, you can take this, plug it on top of your, Arduino, and solder the cables that you are running up to the layout, and then you have a relatively permanent solution.
Okay.
Okay, so while you guys continue to maybe just goof around a little bit, I'm going to go back to screen sharing, and we're just going to kind of wrap this up. And then if you want to keep talking a little bit, we can. Somebody needs to mute because I'm getting a feedback.
Well, I just wondered if Johnny had any questions from anybody on the chat or at all. Okay.
Okay. So the next workshop is going to be next week already. And what you're going to need for next week is a push button. And I'll show you these things in a second as soon as I'm done sharing. A photoresistor, and an infrared emitter and receiver pair. Now those were all things I had on the list previously, so you should hopefully all have those. And that's the end of the thing, so I'm going to stop sharing.
That was a lot to cover tonight, so.
Okay. So Johnny, if you want to put me back on screen. All right. So here's just a standard push button, and I actually pulled off the end off of the one. So if you have these are just a simple push the button and something happens, push the button, push the button. This is the same as this one, only I pulled a little colored cap off of it, because you'll see some sketches show something that looks like this when you're online, poking around and looking at exercises. So just wanted to show you that's the same as this with the cap off.
Just one push button we're going to be using next week?
Yeah, or if you want to have 2 or 3 handy, it doesn't matter. But I haven't completely put together what we're going over yet. But I know what today we kind of talked about output. Next week we're going to kind of talk about input. These are all input devices. A push button. These 2 LEDs are a infrared emitter and detector or receiver. So this clear one sends out an infrared light. It's just like same as the LEDs we're using today, except that the light is in a spectrum that or band that our eyes can't pick up.
And
But
they
then
did
this,
package those in separate packages too.
yeah, you can buy them individually or in pairs or in a whole. Go out on eBay. You can buy like,
I meant the kit they gave us. They made sure they didn't mix them up with the other LEDs to confuse them.
right. So this one will actually, as a receiver, that'll receive that infrared light in that band and then turn on, if you will, or turn off when it doesn't catch it. So what we're going to do next week is put these together, and you put something between them, goes off, open it up again, it goes on. So that would have implications for occupancy detection of track. You know, where is your train? Here's another, this is the other one, the photoresistor. These little guys, the more light they have, I think it is the less they resist, or the opposite. The more light that hits them, the more they resist. So it's just like these resistors we used on here, only it's variable depending on how much light is hitting them. So these are often used on commercial products that for track detection, like grade crossing. Okay, you take the grade crossing signal we just made with our flashing LEDs. You could put one of these under the track. When the train goes over it, it gets darker. That lack of light will then trigger your crossing grades to come on. And then we've
they're
seen
kind of about those photoresistors. I see what they are now. They're these little. I don't know if
yeah,
you
they're
guys
just
can
a variable
sure
resistor. Resistance changes depending on how much light there is hitting them. So they actually, just like turning the knob on a rheostat or a potentiometer, it's just the amount of light hitting it. So by setting a value high and low, when there's enough light not hitting it, you can trigger your crossing grade. So we're going to play around with that stuff next week. So make sure you have one of these, a pair of these.
Okay, let's go with
and
that.
a push
So
button.
a button, a photoresistor,
And infrared emitter and receiver. And if we move along fast enough next week, we'll even maybe try and tie it into our flashing LEDs.
how can you tell the difference between infrared? The one's black and one's white, right?
Right.
And they got 4 pins on them?
Only 2.
Oh, just 2. Okay, there's 2.
Yeah,
All
and
right.
they should have been
There's one with
together.
4 pins on it. Looks like a LED also.
It is. It's a multicolor LED.
Okay.
And if we want, maybe one night we can goof around with that one too, because I thought about
beginners, you weren't kidding.
yeah, I thought about doing that one, but I didn't want to. I couldn't think of a real good railroad application for a single LED. I know a string of LEDs you could change from dusk scenes, change your lighting from full light to dusk to a thunderstorm or something, but I just didn't see a lot of value in a single LED right now. So I'd rather go on and do some of these things that we can use for actual model railroading purposes quickly and easily. So.
Well, long term, there's some things you can do with that RGB, like simulated TV, flat, kind of flickering and flashing. So keep it handy. There are some model railroading applications for it, but they're not simple and straightforward to get. They're not a starter material.
Okay. Yeah, I agree with that. And then going forward a week beyond that, make sure you have a servo, because we're gonna move on to servos so we can try a little animation potentially in week 3. So next week inputs, and the following week servos. So that kind of covers 3 basic subjects: input, output, and servos.
Yeah,
everything
a little servo.
everything we did with these. Yeah, sorry. I'll have to see your screen. Yeah, that's the servo.
Is that the servo? That's what I guessed. Yeah.
Yeah. So everything we did with an LED tonight, you could also do with the buzzers that came in your kit. That's another form of output. Light isn't the only form of output. Sound is also an output. So, you got some of these little buzzers in your kit. You could substitute a buzzer for an LED and make a sound instead of a light too. So
that's all in your sketches, right? That's all listed.
Sure. There's sketch. That's the cool thing is like I said, we don't have to learn how to code. Just go Google it. You'll find whatever it is that you want to try and do. If you Google it, you'll find a sketch for it more than likely that does something very close to what you want to do. And all you have to do is just read through the comments, figure out which line. It's just a matter of changing numbers usually, or copying, pasting another copy of the code. And you're usually pretty much good to go. So I think at that, we'll call her tonight.
Thank you, Chris.
Hope everybody had fun. I hope we didn't bore you to tears. It did go a little slower than I was hoping it would, but we'll get better as we go.
An old man, new tricks.
Well, that's good. So, Johnny, you want to close her up?
I turn the microphone on.
Yeah. Do we have any questions from the chat room yet?
No.
Very good.
No.
Okay.
They were, Marty was over there. He was helping Tony and a few others out with their breadboards and all.
Oh, that's great.
Yeah.
Never thought that we should have somebody offline like that to help the people out in YouTube.
Yeah, hopefully for Lynn, I didn't see Lynn come back say that they found that driver, but hopefully Lynn was able to get the drivers loaded. If not, Lynn, if you're still online, email Chris. Go back, check the post in the community
or better
page.
yet, Andy or Dwight or the Mac guys.
Yeah.
All I would do is point them to them anyway. So they
Yeah.
went through this exercise last week, so they should be able to help them.
But if he wants to hop into an after show after it's created, I'll hop on and we'll try to.
Yeah. Yeah, tell her to go to an after show.
All righty. Well, just wanted to say to go check on YouTubeModelBuilders.com. There you will find the schedules for the Tuesday shows. We also have a schedule posted up for the Wednesday shows, the Arduino workshop now. Those will be the first and third week of each month. I think February, March wound up being on the 1st and the 15th. Other months you'll have different dates there, but all the shows for Tuesday and Wednesday are starting at 8 o'clock Central. Dwight, you need to mute your mic, please. All shows start at 8 o'clock Central, 9 o'clock Eastern time. So check your time zones, make sure you have the right time so you can watch it live. If you missed a show, not a problem. We do record these shows, and they are on our YouTube Model Builders YouTube site. And we do have playlists for them, so you don't have to go hunting through all the videos to find what you're looking for. Just go to the playlist, and you'll be able to find it a lot easier. Also on YouTubeModelBuilders.com, you can check the schedule for the live shows, the once a month Saturday show. We also have the eMag there, so you can sign up. So when the eMag comes out, you can sign up and get a notification by email that it's out. Also want to make sure everybody understands this is all free. Doesn't matter about the shows, the eMag, it's free. Actually free. You're not having to pay for it in any shape, fashion, or form other than your internet connection. But it is all our content is free.
The only advertising we got to put up is Johnny telling you it's free.
Yeah. And there is no ads in the e-mag. That's good too. We don't have ads in our shows. So that's right. Just me advertising. It's free. But yeah, and also when you do sign up, there is an archive for all the e-mags there. So if you're new to the channel and signed up, and you could go back and get all the e-mags all the way back to the very first issue. Because every one of those e-mags, I tell you what, got a lot of good information in them. JD and his team have really done a good job. They've had some really good contributors writing articles for them. So, hopefully everybody enjoyed the show tonight, the workshop. This is one of our first hands-on workshops. We have another one coming up. Starts February the 7th, which will be on a Tuesday night. That's our fine scale build. And we will be building wood kits. That's coming up real soon. We'll have Andy on there from N&W. We'll have Miles Hale, and also Barry from Barry's Tech Show on Tuesdays. All three of those guys will be there, so you'll be able to learn a lot from them, and you'll get to see 3 different versions of how to build something, because there's no one specific right way. So that's going to be a really interesting show too. So with that said, I hope everybody has a good rest of the week. Wednesday is the hump day. We got a Thursday night show tomorrow night, so tune in. Hope everybody does well. Hope you enjoyed the show and you're starting to learn how to use your breadboards and Arduinos together. And we'll say good night. Thank you, Chris, for the workshop. It looks like it's going to work out real well.
My pleasure. Hope everybody enjoyed it. That's the whole point, so we can have all fun